Hey, hello everyone. Give me a thumbs up if you can hear me. Okay, cool. So really great to be here. Really great to speak at Big Data London. I'm a Londoner, so for me this feels like my home conference. The first time I got to speak here. And for those of you who don't know me, my name's David Jayatillake. I am VP of AI at Cube. Before I was at Cube, I ran a startup called Delphi Labs. What we built at Delphi Labs was an AI interface to semantic layers. And so Cube was one of the semantic layers we integrated with, became very good partners with us, and that's how we ended up joining Cube. I also have a blog that some of you may subscribe to, davidsj.substack.com, focused loosely on data engineering, data analytics stuff. So today I'm talking about delivering on the promise of AI, and that's very specifically related to analytics and self-serve analytics. So what we'll cover today is I want to tell you a bit about Cube, and because the semantic layer is fundamental to this, to the principles I want to go through, and also explain how we can help you and what we solve for. And then I'm going to go into the meat of the topic, which is two approaches to how you would use AI to solve self-serve analytics, and then also some evidence about which one is better. And finally, some time for questions. So a little bit about context, problem. So I don't need to talk about this with this audience too much, but we all know the demand for data is growing and continuing to grow. And when I first started out in my career, the demand for data was all internal, right? It was my internal stakeholders at my company that really wanted access to my data. But now, many companies have data products where they're offering consumption of their own data to their customers. And then we also have machines in terms of services, third-party tools via reverse ETL, and now also AI, which needs to consume this data. So it's becoming very difficult. And so if you think about what this leads to, it leads to a number of problems. So you have this data stack complexity, and you look outside of this hall and you see hundreds of vendors, and that's just the tip of the iceberg of the tooling that's out there. And so data teams are having to stitch together all these tools. That then leads to proliferation of siloed data. So when I first started out, siloed data was mostly, again, internal. Like you'd have an Oracle database somewhere or a DB2 database somewhere where you couldn't access the data, and that was a silo between the data you could analyze and the data that was out there. But now we have, we've probably solved for that, and now we have different silos where we've got third-party tools, whether that's HubSpot, Salesforce, even Excel, used as a record of truth, and those are silos in their own right, and that's causing problems. And what happens because of that is that you have many people using many different sources of data to have many different definitions of metrics and entities and dimensions. And so this really causes a lot of problems for data teams today. And so at Cube, our approach to solving this is with the universal semantic layer. So what we want to do is to unify the definitions of metrics. So we don't want to have 3 or 17 different versions of what the definition of revenue is. We want it to be defined once. And if there are 7 genuine different versions, we want to define them properly with good naming and descriptions explaining what they are. And then we also want to govern access to this data. So previously, when you want to give access to your data, it was quite common to give someone a database credential and hope that the way that you've defined your roles and your permissions will guarantee that they don't have access to the wrong data. Now that's really hard on a data warehouse because you don't know the inherent meaning of data from the metadata that you can see in your data warehouse. Whereas with a semantic layer, you have codified the meaning of your data in your semantic layer, therefore providing access to it is much, much easier. And then also optimization. Performance is really, really important. Not only do your internal stakeholders not want to wait 30 minutes for a dashboard to load, you also want your external stakeholders, customers who are using your data products to have really snappy performance on their products, otherwise they're not going to be happy. And so at Cube, we want to solve for that problem as well. And so that kind of brings us to our platform. Cube is the universal semantic layer. We integrate with pretty much any data source that you could possibly think of, whether that's data warehouses like Snowflake, BigQuery, Databricks, lakehouses like Databricks and Dremio and Trino, and we just integrate so widely. And then we have the 4 pillars of what we provide. So we have data modeling. You can define your data model, how your entities, attributes, and measures relate to the underlying data structure. You codify this once in Cube's semantic layer in our data modeling, and you do it once well, and then you consume it many, many times rather than having to rewrite it over and over again. Access control, we provide column level, row level access control on these entities that you've defined in your data modeling, so making it much easier to provide safe access to data to people. And caching, so Cube has a market-leading OLAP cache. So we provide really performant access to these data structures through pre-aggregation and caching of results. So we found that customers can not only save time, but also money on their data warehouse and cloud spend through using this cache. And then their customers also get a great snappy performance using it as well. And we have, market-leading APIs for our semantic layer. We have REST, we have GraphQL, we have SQL, and now AI API as well, which I'll talk about later. And of course, we connect to so many forms of consumption, whether you're building your own application using a front-end framework like React, Angular, or Vue, many, many BI tools, and now other chatbots too. So I want to talk about the different methods now of providing self-serve analytics with AI. So there's 2 core methods that I think about when I look at this. And so the first one is what I'd call text to SQL. So first of all, what is text to SQL? Text to SQL is where you use generative AI to make a SQL query based on a given database schema. So this is like roughly the architecture of how it works. It's pretty simple. And so the LLM is provided the database schema in its prompt along with the user's question. And the user's question is really the part that changes from use to use. And then the LLM runs a SQL query, which is then run against your data warehouse, and the results are provided as an answer to the user. And I think it's become somewhat of a phenomenon over the last 2 years. And so why is that? Many of you will have seen tools like this on LinkedIn or wherever else. And there are many reasons for that phenomenon. Like, firstly, it's easy. It's very easy to go and build a tool like this. There are many examples online of how do you make a text SQL tool in a Jupyter notebook, and you can do it in an afternoon, right? It's not super hard to get started, right? And you can make this kind of application without building a retrieval augmented generation, which is one of the core techniques to building strong AI applications. It looks cool, right? It's amazing. It looks amazing. It talks back to you like Tom Riddle's diary. It's something unfathomable to most, and so it looks as good as magic. But, I think it can have a place. So there are many people out there who need like a co-pilot, or who would find a co-pilot useful, and we've seen this with other programming languages, so why not SQL? And so, I think as a co-pilot for generating SQL code or even semantic layer code, it could be really helpful. And finally, the main reason why it's become such a phenomenon is how much money has gone into it. And I literally mean hundreds of kind of duplicate companies like this have been funded over the last 2 years, including multiple companies in the same Y Combinator batch. There's a lot. A lot's been funded so they can make a lot of noise. So why is it bad? So firstly, it doesn't really know about the world. It knows about your database schema. That's what you've told it about. And so unless you provide it with a knowledge graph or some other context to use in the prompt, it doesn't really know how your specific business works and how your data fits together. So it's going to guess. And so a lot of these tools always give an answer, and always give, or at least give an answer that it thinks is likely to be correct. And so the problem with this is that it's like nowhere near good enough for what a stakeholder would want. And so it kind of drives this inconsistency in answers for non-technical users. And this inconsistency, when given to a non-technical user, is just not good enough. It will never be good enough in business or enterprise to provide that level of inconsistency. And so this is like roughly the shape of the problem. the model doesn't have enough context, the SQL isn't correct, and the LLM tends to hallucinate, and it will always give an answer. And so then we can't trust the data that's been pulled by it. And so that's the end of the value of the tool. So what's text to semantic layer? So this is the second method that I would describe. And this is kind of like what we built at Delphi before joining Cube. So it's using AI to request data from a semantic layer. And I want to really emphasize request. We aren't relying on the LLM to generate true code, just a request to the semantic layer. So why haven't you necessarily heard of it? Many of you probably won't have heard of it. Firstly, it's less common, it's harder to do, it does require building advanced retrieval augmented generation, and also universal semantic layers like Cube are pretty early on their journey to becoming widespread in the market. So why is it better than text to SQL? It does know about the world you've defined, right? So text to semantic layer really relies on retrieval augmented generation to restrict and enrich the prompt with knowledge from your semantic layer. So your organization and your data engineering team or your analytics engineering team or whoever it is who looks after your semantic layer has defined what that data means, how it joins, how it's to be used together, how to aggregate it, and therefore its knowledge is defined and bounded by this work that your analytics and data engineers have put into their semantic layer and have codified it there. And it does decline when it's asked about something not related because it has to answer from the menu on the semantic layer. If it can't find something on the menu, it says, sorry, I don't have it. And that's a feature, not a bug for me, right? Because when you ask a real human data analyst this question, you know, a lot of the time they'll say, sorry, I can't answer that question, or we're going to need to do some data engineering work to pipeline the data in, model it, and then we can answer the question. And like stakeholders don't like that, but it's actually what should happen because you don't want to just guess and make stuff up. That's just it's not going to provide any value. It's going to destroy trust in the tool. And so roughly this is like the flow. The user asks the question, the LLM asks from the semantic layer and the metadata provided by the semantic layer in retrieval augmented generation. Then the semantic layer deterministically compiles that request into raw and complex SQL, runs it against data warehouse, and then you get an answer back. So it's consistent. Because that leg between the semantic layer and the data warehouse is deterministic, it runs consistent code. It's not going to make up a new way to join your tables together or to define your metrics. It's transparent. So one great thing about this is because it's reading from that semantic layer menu, it's going to tell you, oh, I've chosen net revenue less depreciation, right? And it's going to tell that to the user. Now, the user doesn't know SQL, but the user knows your business. And the user knows, I didn't want net revenue less depreciation necessarily, I just wanted net revenue. And it can feed that back to the agent, and then the agent can restructure again and provide a better answer. And we've seen that most of the time, those kinds of situations resolve themselves like this. And that transparency is key to enabling that to happen. And it just enables trust, because if you just have to rely on text to SQL defining the meaning of the data, as well as how to execute the query, there's a bit of a black box there. People don't understand what it's doing and why it's doing it. It can't really be trusted. And so one of the problems that I had at Delphi for a long time was I explained this to people, investors, customers, whoever it might be, and they agreed with it in principle, but I couldn't empirically explain that it definitely was better until a team out of data.world, which is a catalog, who are probably here today, Juan Takeda, who works there, and his team created a new benchmark. And the benchmark is a bit of a mouthful. It's called a benchmark to understand the role of knowledge graphs on large language models, accuracy for answering on enterprise SQL databases. So, a bit of a mouthful, but actually almost the perfect benchmark for this kind of question and for this kind of technology. And so what it was is it used a specific data model. So it was an 11-table data model, which was loosely based on an insurance context. So you had like claims and brokers, etc. And even though it was a small model, it was a rich model with some complex joins going on in it. And what we see here is that text to SQL on its own performs pretty badly, 25% accuracy on a model that small. And even then, when you provide it with a knowledge graph and a huge amount of context about how to use the model, it doesn't really get much past, it doesn't get past 50% here, and anecdotally we've seen it get to that level elsewhere as well. And what you really see is where it starts to lift and go into a situation where it could be near 100%, which is what you need for business, is where the semantic layer is used. So the third column is what DBT Labs replicated for the benchmark. Their semantic layer can't do multi-hop joins, so it couldn't do some of the questions. But then the last column was what we did at Delphi. So we used Delphi with Cube, and we set up a semantic layer in Cube for this data model and ran the questions, and we got 100% accuracy. And so like that really reinforces and proves the point to me is that, you know, I believe that AI, and I not only do I believe, I know that AI needs a semantic layer to provide self-serve analytics to non-technical users. And that I also know that the LLM must natively request objects from that semantic layer naively with no knowledge of the underlying data structures. This request should then be deterministically compiled into complex code based upon the definitions provided by your analytics and data engineers. So in conclusion, I think text-to-SQL, you know, has a place, and I think that place is as a co-pilot for people who really know SQL already and who know the data already, and then it's fine. I think it's very helpful. I tried out Snowflake Copilot and Databricks Genie, which are designed for that purpose, and they did a pretty good job. I'd recommend using them as a co-pilot, but they're not suitable for self-serve analytics, especially for non-technical users. And text-to-semantic layer is the method that can work for that, and that's what we've seen. So, a few resources before I go into Q&A. So, have a look at Cube Cloud. It's very easy to find us. Cube is also the open standard for semantic layers. We have an open source product which is fully usable, including compilation, which is unique in the market. And also check out our AI API, which implements a lot of these features that I described and the method I described for text-to-semantic layer. And there's some other resources for you too. So, I'm going to move on to Q&A. So, does anyone have any questions? There's one down here. Oh, is the mic coming? Mic is coming.
Hello. Yeah. Hi, David. I'm Rohit. I have a question. Can you hear me now? I can hear myself. Okay. The question is related to the where clauses. So maybe like you are asking for a particular product and user has not typed a correct value, and in your database the product name can be called with specifically with uppercase or lowercase letters. So how can we solve this? Like, I mean, in Cube you have metadata,
yeah, so
but that can solve, like, I mean, more or less for a limited number of data. Like, I mean, if we have like 10,000 of distinct values,
yeah.
And if I type like give me data for like a product XYZ, so maybe I don't have XYZ, it might be XYZ 1, 2, 3, something like that.
Yeah. So this is a problem that we've seen, and we have a design for solving, like specifically in our AI API, but there's a generic method to it. So what the question described was, what happens when someone wants to refer to the value inside a dimension? So let's say it's like a product and it's like a shoe, and you say, oh, show me the sales for like Onitsuka Tiger shoes or something like that, right? And people don't, like, the question doesn't necessarily refer to the object from the semantic layer, which is the product dimension. It's referring to a value in it, which is the shoe name, right? And so this is where retrieval augmented generation needs to be really advanced for this kind of product, and that's what we're building. So what you need to do is build what we call like a value search system, where you can either use a vector database or a normal database to help a customer elect to store the values of certain dimensions, and therefore when you run retrieval augmented generation, you find values inside those dimensions as well that could be relevant to the question, and then you feed that key value pair of dimension equals like product equals Onitsuka Tiger into the prompt. Right, that's the way loosely it would work. It's a bit more complicated to implement than that, but that's roughly the principle, and that's how it would work. Any other questions? Oh, again. I think it's for everyone else here.
What metadata do you store in the semantic layer?
Okay, so what metadata we store in the semantic layer? So it's really like up to you. So what I would say is you should store the metadata in the semantic layer in such a way that, imagine if an expert from your industry joined your company tomorrow, could they understand your semantic layer, right? That's the way I describe it. So you should, firstly, the first type of metadata is how you've named things, right? If you've named things like, name a customer, don't name it some weird abbreviation. That makes it easy for AI to find that term in the semantic layer. Then also descriptions. So we find that descriptions are really helpful, and you can be pretty verbose in those descriptions because AI is not going to do TLDR, right? It'll read the whole thing. And then secondly, like duplication, you want to have the terms in your metadata as far apart as possible, so the names of those objects shouldn't be very, very similar. And when you do those things, then you've got rich metadata in the semantic layer for AI to use. Any other questions? There's one at the back. Oh, two at the back. I can't hear you.
Hi David, this is Shashi here. Thing is, I'm also writing a text to SQL for my enterprise. Okay. Now the challenge which I'm always being asked is like, why do you want to build it? Because Databricks and Semantic are anyways building it. It's just a matter of time where they use an API call or it will access when not technically interested in also talk about data, right? What is your take on that?
Yeah, so it's definitely happening, right? So Databricks, Snowflake, GCP as well, they're all moving towards building this. And so I've looked at Snowpilot and Genie, Snowflake are building Cortex Analyst, Databricks are accepting semantic information into Unity Catalog. So this is happening, and it will happen. And what we've seen is that kind of message, that text to SQL doesn't work very well, has been heard, because all of the providers are at least using semantic models as a context feed. They may not be forcing their systems to be constrained to the requests, like I described, because that's harder to build. It requires building a compiler. Although GCP has that because they bought Looker and they've got LookML, which does that for them, right? But yeah, Databricks and Snowflake are moving along that path, and we think in a year or so they'll probably have got there. Anyone else? I think we've got time for one more. No? Oh, one more. Francesca. I can't hear you.
Okay, now I guess you can hear me because I hear myself. Can you hear me? Yes?
I can hear
Okay,
you.
so this thing of text to semantic layer, is it a thing that you heard anywhere else, or is just your thing?
I mean, it's what we built at Delphi, and then there's like one or two other companies out there who are also doing it, and now it's something that we built at Cube. I feel like it's becoming a movement that people realize that this is what needs to happen.
Yeah, and I agree. Okay.
Okay, thank you everyone.